Section 10.3 is where you're going to find the areas of regular polygons. So if you remember, a regular polygon is where you have congruent sides and all of the angles are also congruent. So this is just showing you that we're going to, you can circumscribe a circle about any regular polygon, which means that you can put it on the outside of it. It says the center of a regular polygon is also the center of the circumscribed circle. So what that helps us do is we can try and figure out what these angles are on the inside by using the fact that a circle always adds up to 360 degrees. The radius of a regular polygon is the distance from the center to the vertex, so from there to there. The apothem is the perpendicular distance from the center to a side. The reason why that's important is because you're going to use the apothem here in a little bit to find the area of a regular polygon. So the first problem is not too bad because you're just finding some angle measurements. So here is my picture, and it's wanting me to find what the measures are for angle 1, 2, and 3. Well, angle 1 is this angle measurement from here to there. So that means that I want that section of my pie, if you will, because remember we're going to use the fact that the circle is circumscribed around it. So that means that all of these angles have to be 360, while all of those angles are also congruent to each other. So I could take 360 and divide by how many sections I have, which are 5, and figure out what each angle is. So that means that angle 1 would be equal to 72. The next thing I could do is, if I know that this big angle is 72, the apothem, which is this line that they drew perpendicular to the side, I know that it will bisect that angle. So I can take 72 divided by 2, and that will give me angle 2, which is 36 degrees. Now, to find angle 3, I know that this angle is 36. I know that this angle is 90 because it's an apothem. So since I have 2 of the 3 of my triangle, I could take those 2, subtract it from 180, and find my missing angle measurement. So your third angle would be 54. Okay, pause the video and see if you can do it on the got it question. So in the got it question, they're giving you a regular octagon. So that means to find angle 1, you would take 360 and divide by 8. So angle 1 should be 45. Angle 2 would be when the apothem bisects that angle, so it would be 22.5. And then you would take 180, subtract away 22.5 and 90, and that would give you your remaining angle 3, which is 67.5 degrees. Okay, so the last note that it just put on there was that if two figures are congruent, then it should make sense that their areas are equal. That's really not mind-blowing there. But the next theorem at the top of the next page is our formula of how we're going to find the area of a regular polygon. And that formula says that I need to do 1/2 times the length of my apothem times the perimeter of my polygon. So there's a couple things that you have to have. You have to have the perimeter, and you have to have the height or the length of the apothem. Okay, so here is my first picture. It's giving me a regular decagon. So a decagon is going to be 10 sides. So I need to know the length of my apothem. Well, they gave it to me from my picture. It's hard to tell because should say 90-degree angle there. So they already gave me my apothem, which is 12.3. I can find my perimeter very easy as long as they give me a side length. So since they gave me this side as 8, I just took 8 times 10 or added up 8 10 times, and so your perimeter should be 80. So all you should be doing is just plugging in those numbers. So I would do 1/2 times 12.3 for my apothem times 80 for my perimeter, and I would get 492 square inches. Pause the video and see if you can do the got it question. So in the got it question, they didn't give you a picture. They just said the area of a regular pentagon with an 8 centimeter apothem and 11.6 centimeter sides. So wanting to know the area. Well, they gave me the length of the apothem. My perimeter, all I would need to do is take 11.6 times 5, and that would give me the perimeter. So I did 1/2 times my apothem, which is 8, times 58, which is what I got for the perimeter. So your area should be 232 centimeters squared. Okay, The last problem is one that's a little bit more challenging just because of the fact that it's involving more of those 30, 60, 90 triangles. So here it says a honeycomb is made up of irregular hexagonal cells. The length of a side of a cell is 3 millimeters. What's the area of a cell? So what I did is I just made a hexagon to try and give me an idea of what it looks like. Then I labeled one of the sides as 3 millimeters. Remember from problem 1 that my center is here, and that if I go from my center to the vertex, it creates a radius. Remember how we found those big chunks for the area or the angle measurements? So remember in this case I had 6 of those, so I would take 360 divided by 60, and then I know that one angle would be 360 divided by 6, and I would get 60. Remember that we also took the apothem and it bisected that angle, so I know that this angle right here is 30 degrees. The reason that's helpful is because my apothem creates a right triangle, and so if this angle is 30 degrees, then I can help figure out the height of my apothem because it doesn't tell me from this picture. The only thing that it tells me is the side length, which would help me find the perimeter. So my apothem will bisect also my side length, so I know that the side opposite my 30 degrees is 1.5. The reason all of that is helpful is because I can use those 30, 60, 90 formulas to find what my apothem would be. So this side would be my short leg, the apothem would be my long leg. So I would want to use one of these two formulas for 30, 60, 90. I would want to use the long leg formula since that's the one that I need to find. So I would do the square root of 3 times my short leg, which is 1.5. So if I left it in radical form, it would be 1.5 times the square root of 3. Now, sometimes again, these questions say leave it in radical form. Sometimes they want you to change to a decimal. So if you changed it to a decimal, then it would be approximately 2.60. Okay, so now I have my apothem height. So now I can plug it into my formula where I do a half times my apothem, which we just found is 2.60. Now I have to take it times my perimeter. So remember I have my side length, which is 3. I have 6 sides, so I would need to do 3 times 6 to get my perimeter. And then times all those together, so I would approximately get 23.4 millimeters squared. Now those problems are challenging because there's quite a few steps involved. So remember you want to first start by what's your kind of central angle. So what are your angles that you're dealing with? Bisect that so you can see what angle is here, and then use that also bisection of the side length to find that other piece. Alright, see if you can try the next one. On the last question, you still have a regular hexagon, so I went ahead and drew another hexagon. My side length is 16. Again, since it's still a hexagon, I know that those big angles are going to be 60 degrees, so that my apothem bisects it. I know this angle right here is going to be 30 degrees. I also know my apothem bisects that side, so I know this side opposite 30 degrees is 8. So I would want to again use my long leg formula where I do long leg equaling square root of 3 times short leg. So I would do the square root of 3 times 8 to find what my apothem would be. So that would approximately be 13.9. And then you also want to find your perimeter, so I would do 16 times 6 since I have 6 sides to get 96. So over here I would do a half times 13.9 my apothem times 96, which is my perimeter, times them all, and I would get 667 square feet. Now if you remember on the previous section I said be careful when you round. So if you round at the part where you're finding that apothem, you have a little bit of a rounding error in there, so it will change your answer compared to if you didn't round to the end. So since I rounded here, I got 667, but if you were doing the problem and you left it as 8 square root of 3 over here and you typed it in your calculator one big string, so a half times 8 square roots of 3 times 96, then you would end up getting 665 because you didn't put in that rounding error. So it does make a difference when you round. So the best answer is when you round at the very end, because then you don't get that rounding error in there. Okay, I understand that these last two questions are very challenging, so you need to let me know if you need more practice or if we can go through another one together.